All right, hello everyone. My name is Danica Donahue, and I'm the Technical Workshops Director for the Society of Women Engineers. In this second workshop, I will be teaching you the basics of Python, and this is a part of the Python workshop series that I'll be doing. The next time I'll show you how to draw with turtles, and then hopefully the third workshop, we will actually start making the game. So assuming that you all have downloaded or installed Python, I'll just get into the basics. So in order to access idle, I have a Windows computer, but just pull up the idle program, and I just do that by searching idle in the search bar in the lower left corner of my computer, and then just pull it up. Takes a little bit to load, and then I will share that with you so you can see what I am talking about. So this is the Python shell. See all my million tabs open. But this is the Python shell. So this is what will open up when you first open idle. I'll just be calling this the Python shell or the main shell. But if you ever want to open up a new shell, you just go to File and then New File. And then I'm not sure if you can see it or not, but just an untitled window comes up. And this is where we will be, it just looks like this. Let me show that. And this is where we'll be saving functions or saving particular code that we're going to run. And then after it's saved and it runs, the output comes in the Python shell. So the Python shell is kind of like the command window if you're familiar with MATLAB. It's kind of just where all of the output, and you can also input stuff as well. But if you're running functions or if you're running code that you saved and you're recalling it and running it, that's where the output will spit out. It'll spit out into the Python shell. All right. So now I will just start covering the basics. All right. So computation, in Python, we can add, subtract, multiply, divide, assign variables, etc. Okay, so in this example, I typed out division. I typed out 5,000 divided by 5, and it calculates the answer and spits it back out for me, which is 1,000. In this line of code, I added, and here I multiplied, and here I subtracted. In these following lines, I assigned values to variables. So I said that the money saved variable was equal to 10,000. And whenever you're using a variable name that is multiple words and you're separating it by spaces, you're going to need to use underscores. Python is very fidgety, but you need to use underscores like when you're intending to use a space. If you ever mess anything up, it's not a big deal, but you will get like a red error message. And sometimes this can actually be helpful because it'll tell you what you messed up. So in this line of code, I try to divide money saved divided by money saved each month. And it tells me that I never defined what money saved each month was. I never assigned it a value. And that is true because I made a typo. I meant to say money spent each month instead of money saved each month. So here I just corrected the error. I just typed out these lines again. And then this time I divided by money spent each month like I originally intended, and it gave me the answer. Okay, so that's just basic computation that we can do in Python. Another key thing to know about Python is strings, which is just like text basically. You can use a variable to label a string and use quotation marks to tell Python that it is a string. I like to use the print function to show the value of a variable. So in this example, I said I is equal to the string I love ice cream. I printed it back out and it displayed it. And I did the same thing with G is equal to the string gorillas are cute. And then I printed the variable and it printed out the string for me. You just need to make sure that you're consistent when you use quotation marks. So strings, I'll talk about 3 single quotes later, but for the basics, you want to be using a double quote or a single quote, and you need to be consistent. So for I started with double quotes and I ended with double quotes. For the G string, I started with a single quote and I ended with a single quote. If you start with one kind, like say I start with a double quote in this example, and I end with a single quote, Python doesn't like that. It's very confused because what it does is it looks for a quotation mark of a particular kind, and it scans until it finds a quotation mark of the same kind, and then it knows that it needs to stop the string. So in this example, Python reads this, it sees a double quote, and it keeps reading until it finds another double quote, but it never finds one. So it's very confused where the string is supposed to end, because to the computer, you never told it where to end. Another example of an error is in the L line, the string. I started with a single quote and I ended with a double quote. You just need to make sure that you are consistent, whether that be a double quote, ending with a double quote, or starting with a single quote and ending with a single quote. And you also just need to close the string. Here I didn't close the string, and here I also didn't close the string. And so I got errors in both of those strings as well. 3 single quotes. To make multi-line strings, you can use 3 single quotes and hit enter in between lines. Show you an example of that. So here I just did a joke in this string. So I typed out, how do dinosaurs pay their bills? And then I clicked enter to get a string on a different line that says with Tyrannosaurus checks. So when I print it out, it looks like multiple lines. So to do that, you just need to make sure to use 3 single quotes instead of the double quotes or just the regular single quotes. Okay, so as I said before, Python expects there to be text after a quote mark and for the text to end when it meets another quote of the same kind. So some common errors are shown in the picture below. So I'm trying to assign this statement, he said, aren't, can't, shouldn't, wouldn't, to the variable called crazy. And I'm getting an error message that says invalid syntax, and I'm also getting multiple colors within this string. If you do it right, like in this picture, the string should all be green, but it's not. We have some black text right here, and we also have some black text right here. So in Python's mind, what the computer is doing is it sees this single quotation or this single quote mark, and it knows to end the string when it gets to another single quote right here. So it thinks this green section should be one string. Then it reads this random text and it's confused because it hasn't run into another quote yet. It hasn't run into another quotation mark, so it doesn't know what to do with that information you gave it. Then it runs into a single quote and it knows it needs to start a string again until it meets another single quote, and then it ends the string. So this is our second string in green. It doesn't know what to do with this information. It hasn't run into another quote mark yet. It runs into another single quote. It looks until it finds another quote of the same kind, single quote, and to end the string. So this green part will be the third string. So Python in this case is very confused why you are assigning 3 different strings to one variable and you also have all this additional text in here that it thinks that you don't need. So it gives you a syntax error. So to fix this problem, you can use 3 single quotes, which allows you to use double and single quotes inside of one string. So here I use the 3 single quotes to say he said, aren't, can't, shouldn't, wouldn't. So it's a similar concept. It sees the 3 single quotes to start the string, and it's not going to stop the string until it sees a quote of the same kind. So it goes all the way till the end when it sees these 3 single quotes, and then it knows that is a whole string. So that is a way to just use double quotation marks and single quotation marks, or apostrophes in this case, because they were in contractions inside of one string. All right. So to recap, 3 single quotes can be used for multi-line strings and for using double quotation marks and single quotation marks inside of a string. You can also embed values into code, and we do this by typing the percent symbol and S as a placeholder. When we use the print function, we tell Python what to switch the placeholder with. So in this example, I said that my score was equal to the value of 1,000. And then a message, I scored blank amount of points. Then I told Python to print the message out, and then you just type this little parenthesis like you used before, and you tell it the variable that you are going to switch out this placeholder with. And then it will print out I scored 1,000 points. So it takes the my score value, 1,000, and it puts it in where the placeholder was when you print it. You can also do this with multiple placeholders. So in the next line, I say nums, that variable, is equal to the string. What did the number blank say to the number blank? Nice belt. Then in this line, I tell it to print out the string and to substitute the placeholders here and here with the values 0 and 8 in just parentheses if you're doing more than one, and then with separating by commas like this. And then when it prints out, it says, what did the number 0 say to the number 8? Nice belt. You can also print short strings, and you can multiply them. So here I multiplied the string ha by 10, and it just prints it over and over and over 10 times. All right. Next, we have lists, which are more useful than strings because they can be manipulated. So this is a little bit complicated, or just confusing, I would say, especially if you already know another coding language. I know MATLAB, and when we work with MATLAB, that in a matrix, the first item in the matrix is in position 1. But in Python, the first item in a list is actually in position 0. So we don't start numbering at 1, 2, 3, 4, and so on. We start numbering at 0, and then we go 1, 2, 3, 4, and so on. So in the next picture, I will show that I printed entry 2, which is actually the third item in the list. So here, like I said before, I'm using a variable that is multiple words separated by a little subscore. And so I'm typing out all of these items for the potion that I'm supposedly making and all these different little strings. So I print it out, just looks good. And then I'm telling Python to print the second position of the potion ingredients list. So the second position is actually the third entry because we start at 0. So in this list, this is position 0, this is position 1, and this is position 2. You tell it to print out position 2, which is the third item, and that is I have newt. We also can change positions in lists. So here I'm telling it to change position 2 to say snail tongue instead of I have newt. You print it back out, and the I have newt has been replaced with snail tongue. So you can manipulate lists, which is really handy. You can also use a range function, which I will talk about later. This is a built-in function into Python. But what this range function really means is that the first number is inclusive and the last one is not. So we will, in this line, I said print potion ingredients from position 2 to 5. And what that means is it'll print position 2, position 3, and position 4, and it doesn't include the last number. So we don't include 5. We go up until 5. So it did that. It printed out snail tongue, bat wing, and slug butter. So it's just, excuse me. So it starts 0, 1, 2, 3, 4, 5. So 2, 3, 4, right here. There are also many things that we can do with lists. We can add things, delete things, add and multiply lists. They can also include words and numbers. A new list can also consist of lists. So in this example, we have over here, we have numbers and strings. So we have the strings I ate scoops of ice cream and the number 6. And then we wanted to print that back out, and it looks just like this. Here I have just a list of numbers, and here I just have a list of strings. In this line of code, I'm making a new list that has the two lists inside of it. So here I have one list, second list, and here I've put them inside of one list together. You can also use the append function to add particular things into or onto the end of a list. So here I say append mermaid tail scale onto the potion ingredients list. When I print it back out, now it is one entry longer and it has this mermaid tail scale on the end. You can also use the delete function, or just del for short, to delete certain entries out of the matrix. Here I'm saying delete what's in position 5. So we go 0, 1, 2, 3, 4, 5. When I print it back out, there should be no snake dandruff. And that is what we see. Let's see, we can also add lists. So here we have list 1 is this list of 1, 2, 3, and list 2 is I love chocolate. When we add them together like this, it's kind of similar to this, except we didn't do it with a syntax of where it's one list, comma, another list, where we have these brackets inside. We're adding them together. So essentially that takes off the brackets of the old lists and then just puts them into a new one. So it says 1, 2, 3, I love chocolate. Okay. Also, you can multiply lists. So in this line, I have list 1 and I want to print it out 5 times into one list, which you can see here 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. All right, next up we have tuples, a list that cannot be changed, and this could be helpful if you know that you're coding something that you're never going to need to change. It looks like a list, but we use the parentheses instead of like the brackets. And let's go to the next slide. And if you try to change it, you will get an error message. So in this example, I tried to change the 0th position to a 4, and it tells me right here, the tuple object does not support item assignment. You cannot change it because it is a tuple. We can also make maps in Python, and this uses the kind of like squiggly brackets to enclose things. In a map, there are keys and values. So a key is kind of like, it's kind of like a variable almost, but it's what you're storing the information in. So like if I said x is equal to 10, the key is kind of like the variable in a map sense. So for example, in this map that I made of favorite sports, the first key is my name, Danica Donahue, and then it says there's a colon, and then it says my favorite sport, which is synchronized swimming, and then separated by commas to separate the next key and value. This is my sister's name and her favorite sport, and then my other sister's name and her favorite sport. So this is what a map would look like if we drew it out. You have all of the keys, which are all of my sister's names and my name, and then the values that I assign to each person's name, which are these, which are all of our favorite sports. So this is what it would look like. So you see, these are kind of like variables, and these are the values that we're assigning, but these are also just strings, kind of. So now, if I want to print out part of this map, I want to print out Colette's favorite sport. So I say print out the value for the key Colette Anderson from the map called favorite sports. And it tells me what her favorite sport is. It's volleyball. So this can be pretty, I'd say this would be pretty helpful. Like if somebody gave you like a very, very, very long list of something and you were going to be needing to search it for a particular value, and you didn't want to search through it every single time, you could just enter it into Python. And sure, that would take a long time, but you would save time in the long run because you could just have the computer tell you what the value is by typing in this short line instead of having to look yourself through a super long list to find it. It's kind of like, this line is kind of like a control F in like a spreadsheet. It'll just tell you the value of the key in a map. Oh, I do not know why that is like that, but anyway, so like I said before, we can use the delete function. So here I just deleted the key Danielle Donahue from my map. So if we printed it out, there's like this whole thing wouldn't be in there. So just say Danica Donahue synchronized swimming and Colette Anderson volleyball, which it does when we print back out. Alrighty. Oh, and here also we can just redefine the map, or we can redefine a value of a particular key. So in here, in this line, I say favorite sports of Colette is actually now equal to soccer. So I did change the map a little bit when I was just coding. I could just got rid of our last names. So it would be exactly the same thing, just without these last names. And then I got rid of Danielle's. So it's just Danica, synchronized swimming, Colette, and volleyball. Like right in this line. But then I'm changing the value of the key. I'm changing Colette's favorite sport to soccer. This is kind of like what I did with the list. I changed the value in a list to something different. I replaced it by saying the list name, saying the position, and then saying what I wanted it to change to. This is similar. I'm saying the map, I'm saying the key, and then I'm saying what I want to replace it with. When I print it back out, we see that Colette's favorite sport is now listed as soccer, so the switch was successful. Yeah, so as I said before, this can be useful if you have a long list that you don't want to search in over and over for different values. You could enter it one time and then use the print function to tell you the value, so you don't have to search for it. It's kind of like a Control F in Word. It's also easy to quickly change the values of a key. So it's different than tuples, which cannot be changed. Next, we'll be talking about if and else statements. These kinds of code run when the if or else statement is met. So say someone in real life said, like, if you are over 5'7", stand on this half of the room, else stand on the other half. So that's just an example of an if and else statement, in everyday life. But this is how if and else works in Python or other programming softwares. If something is true, you will do one thing, else it's not true, you do something else. Okay, so here is an example. So as I was saying before, in idle, when you're making a new function or you're saving something, you need to click the file and then a new file to get a new window in order to make the short code program that you can save. So I did that. I went to idle, the Python shell window. I clicked file, new file to get a new window. And then I typed out the if else statements with the results if they were true. So for example, in the first line, I say x equals int of input, what is your age in years? I typed int input, what is your age in years, and assigned it to the variable x. Then I say, if x is greater than 20, you're going to print you're getting old, else print you're still young. So when we run this code later, what we would expect to see is Python will ask the user the question, what is your age in years? Whenever it says an input and then something in here, that means that the computer will be asking the user for their input. It will be asking them a question and they will need to physically type something into the software. So the person will be asked, what is your age in years? They will put in a number. So for example, right here, after I saved it and I ran it, it asked me, what is your age in years? I typed in my age, I'm 19 years old. And since X was not greater than 20, so if X was greater than 20, it would tell me I'm getting old. This is not true. So the else statement is true because I'm not over 20. So it tells me you're still young, as we can see right here. Okay. And also just an important thing, like when you're making functions or if else statements in this new window or this new shell, you just simply go to file, save as, and I usually just save the file as the name.py just for Python. But yeah, it's pretty simple. It's just like you would save an ordinary file. And then you go in the Python shell, or actually no, right here, let me show you. Right here, you're just gonna go to run module, and this save code will run in the Python shell. So like I said, the Python shell is kind of like the home base. It's where the output of the ran functions are going to come out. So here it tells me it ran the file age.py, which is what I called this saved if else function, or the if else code, and then it ran. Okay, important things to know for if-else codes. I like to think that the if-else, if something is equal to, it's not always going to be equal to because it's an if statement. So that's how I remember that we need two equals. Equals to the Python is like definite. You're saying that we usually use that for assigning variables, like x equals 10. It's definite right now, the variable x is equal to 10. But in if-else statements, we're going to need to use two equal signs in a row, just like this. And I remember that because it's hypothetical. It's not necessarily always going to be equal to a value. It could be, it could not be. For not equal to, use the exclamation point and then an equal sign. Greater than, we just use the greater than sign. Less than, the less than sign. Greater than or equal to looks like this, and less than or equal to looks like this. We can also combine conditions in if-else statements. So we can use and we can also use or. So for the and statements or the if-else statements with ands, both of the conditions need to be met for the if statement to run. And if one isn't true, if the other isn't true, or both of them aren't true, both of them are true in all three of those scenarios. So the if statement will not run. So this is an example that I did about telling people if they should apply for a summer internship program. The interest, I just assigned the variable interest to the input. Are you interested in an engineering summer internship? 0 equals yes, 1 equals no. That is what the person will be told. They will either input 0 or 1. Yes, I'm interested, or no, I'm not interested. Also, an important thing that I should probably touch on is whenever I use the input, you're usually going to need to use the int along with it. And what that does is input, you are going to type in a number or type in a particular, usually a number. So in this example, it asked me like what my age was, and I typed in 19. But the way that Python, the software tells itself the information that you input, the way that it kind of like stores it as a string. And strings have those quotes on them, remember? So it's not just going to be stored as 19, it's going to be stored as quote 19 quote. And that is different than 19. The number 19 is different than quote 19 quote. It's seems kind of silly sometimes, but that's true. It is a different thing. One is just a number and one is a string of a number. So what the int function does, or this little int, what that does is it chops off the quotation marks of the string to just give you the number. So in this example, what would have happened if I didn't use int is I probably would have gotten an error. So I inputted that I'm 19 years old, and Python will store this as the quote 19 quote. In my if statement, it's just looking at numbers. It's not looking at strings. So the computer will try to run the if statement, and it's going to be super confused on what to do because I gave it a string, or it's storing a string for my age in the variable x, because that's where we're storing the input. And it doesn't know what to do because I only gave it strings and it needs numbers. There's no quotation marks here. So the Int function simply cuts off the quotation marks in the string and converts it into a number so that this if statement will run, because we just use numbers in the if statement. So that is important. Usually if you're just using the input, you're usually also using the int if you are saying that things are just numbers, which I am in this case as well. So I ask the person, are you interested in the internship? Yes or no? And then I also ask them, would you like to spend the summer in a state other than Minnesota? Yes or no? So in both of those cases, they're going to type in numbers. Python will store those as strings with quotes on the ends of their answers, their inputs. The int function will chop off the quotation marks, so now it's just numbers. And so interest will either be equal to the number 0 or the number 1, depending on if they're interested in engineering summer internship. And the value travel will also be equal to the value of 0 or 1, depending on if they want to travel or not. So now I'm saying in my if statement, I combined conditions. We not only does the person need to want or need to be interested in an internship, they also want to spend the summer in a state other than Minnesota. And if both of those conditions are true, the person will be told, you should apply for our summer internship program. Else, they will be told, our opportunities may not be the best fit for you. So what falls under the else umbrella? The else umbrella could be they may not want an internship, they may not want to travel, or they may not want to do either. But in all of those scenarios, they don't want to do both things. They aren't interested, and they need to have both. And if the if statement is not true, the else statement will run. And you can also do or statements as well. So like you could do, so I could have changed the code to say something like, if interest is equal to 0 or travel is equal to 0, print, you should apply for our summer internship program. Else, and then just end the statement. You can also just do if statements. So if something is true, do this. You don't necessarily always have to have an else or an else if, which you can just do if statements as well. But for ors, one or the other needs to be true, and then the code will run. For loops. For loops are super handy, and this is just for if you want to do things over and over and over, but you don't want to do them over and over and over. You're going to make the computer do it. It's very, very handy. So in this example, I am saying found coins is equal to 20, magic coins is equal to 70, and stolen coins is equal to 3. Then I'm saying coins is equal to found coins. So found coins is equal to 20 right now. Coins is equal to found coins. Coins is equal to 20 right now. Now I'm saying for week in the range from 1 to 53. This is also just like to jog your memory about range. It's not inclusive of the top number. So we're going to go from 1 all the way up to 52, but we're not going to do 53. So for week in that range, the coins is equal to the coins plus the magic coins minus the stolen coins. And then we're going to print the string week blank equals blank. And then with a little parenthesis, I tell it what to change the placeholders with. So this should be the week, and then week, which is just the number of the week, equals the amount of coins, which is, and then I ran it, saved it and ran it, and that's what I get. I get week 1 all the way up to week 52, and it tells me the value of the coins for every week. So that was really handy because I didn't have to do all of these calculations, and I didn't have to type out week 1 is this, week 2 is this. It just did it all for me in like a second, which is really, really handy. So I get this can be kind of confusing. It took me a while to understand for loops, but basically what it does is it's just going to loop through all of these values that I told it to. So first we're going to start at week 1. Let's start with that example. It's going to say coins is equal to coins plus magic coins minus stolen coins. Okay, so coins for week 1 is equal to found coins. So that's equal to 20 right now. Plus the magic coins, 20 plus 70 is 90, minus 3 is 87. And then we're going to print out week. What's the week number right now? We're at number 1. Week 1 is equal to the value of the variable coins. And we already said coins was equal to 87. So we should get week 1 is equal to 87. And then we're going to go to the next number. We're going to go to number 2. We're going to go coins is equal to coins plus magic coins minus stolen coins. But now, now coins isn't equal to 20 anymore. We already did the for loop beforehand, and we said that coins is now equal to 87. So then we're going to do 87 plus 70 minus 3. and then we get 154. And we just keep on going all the way throughout the weeks. So it's important to remember that the variable that you're using the for loop, the value of it might be changing. And here it changed. Before it was 20 and now it's 87. So it always keeps the new value or the newest value of the variable. All right, next is while loops. A for loop is a specific length, but a while loop is used when you don't know ahead of time when the loop needs to stop. Trying to think of so like an example of this would be like if you're in gym class and like your gym teacher tells you you need to run 10 laps. That is a specific length. You know that you need to run 10 laps around the track and then you get to be done. But if your gym teacher says, while you have not burned 1,000 calories, you need to keep running, you don't know when you're going to get to be done before you start running. You just get to be done once you've burned 1,000 calories, but there's no set length. You don't know. You don't know ahead of time, and you didn't specify that. He didn't specify that. Your gym teacher didn't. So that's kind of just a relatable example. But in code, it's very similar. While a while loop is while something is true, do this section of code. And we don't know when it's going to end. The computer is going to keep track of that for us. So in this example, I say x is equal to 45, y is equal to 70, while x is less than 50 and y is less than 100, with a little colon, x is equal to x plus 1, y is equal to y plus 1, and then print the pairs of x and y. So for this loop to run, the while statement must be true. X must be less than 50 and y must be less than 100. So starting out, we have x is equal to 45. So is that less than 50? Yes, it is. And y is equal to 70. Is that less than 100? Yes, it is. So the while loop will run because the while statement is true. X is less than 50 and y is also less than 100. So the while loop will run and we're going to add one to x and 1 to y, and then we're going to print those values out. So here we started at 45 and 70. So we should expect 45 plus 1 is 46, and 70 plus 1 is 71. We should expect the pair 46, 71, which is true. So now we don't use these values anymore. Now x is equal to 46 and y is equal to 71. And now we do this again. X is still less than 50, y is still less than 100, add 1 again and print. So now we have 47 and 72. While statement still true, keep going, keep adding 1, keep adding 1, keep adding 1. But now we have x is equal to 50. So now is x less than 50 and is y less than 100? Y is less than 100 because it's 75, but x isn't less than 50 anymore. It's equal to 50. So we can't be, this statement won't run anymore. So that's an example of a while loop. Next up, we have functions, a chunk of code that tells Python to do something. A function has 3 parts, a name, parameters, and a body. So in the example above, the function name is function1. The parameters are fname and last name, which is just short for first name and last name. And the body is the print line. So the body is kind of just like the actual part of the code that's telling Python what to do. And then the function name is just function1 in this case. So in this example, I am defining function1 as first name, last name. So these are like the parameters. The parameters are kind of like the input into the function, what the function needs to run the code and to give you back the output. So it's called function1, and then I want it to print hello, blank, blank. Then I tell it what to substitute these placeholders with, first name and last name. So it should say hello, first name, last name, whatever the person's name is. So then I ran it. So I say function1. So this is one way to call the function. You can just type out the function name just like this, and then input the parameters. Parameters are first name and last name. So our name is Mary Smith. And then it prints it out. Hello, Mary Smith. Or you can also define the variable, or you can define the parameters beforehand and then just call the function like this, and it'll do the same exact thing. I personally like this option better. It's 2 lines of code instead of 4. So just call the function name, parenthesis, and then input the values of the variables or the parameters that the function needs to run the code. Okay. A function is often used to return a value using a return statement. So I guess it's a little bit different than like the print function. The return will kind of just okay. Yeah, the return is just giving, in this example, is just giving me the calculation of pocket money plus job money minus spending. And then it's just printing out the value of the function. So yeah, the return is basically just calculating it for me. But again, we use the print function to actually show the value that we get from that function. So in this example, we have the function is called savings, and the parameters are pocket money, job money, and spending, as we can see here. And then it will calculate what pocket money plus job money minus spending money is. And here we tell it to print. So we say print the name of the function and then the values of the parameters. So we have $10 for pocket money, $20 for job money, and $15 for spending money. It calculates this out. So I'll do 10 plus 20, which is 30, minus 15, which is 15, and it prints out that value for me. All right, modules are used to group functions, variables, and other things together in larger, more powerful programs. The import command is used to tell Python that we want to use a certain module. So modules are kind of like fancy features that Python has. So in this example, I am importing the time module, and we can call functions within this module with the dot symbol. So in this example, I'm importing time, and I want to print the time.asc time. So this is the name of the function, and this is the module that it's in. So the ASC time, what it does is it prints out it finds the exact time, and then with the print function, it's going to print out the exact time for me. So I was making this code on November 22nd of this year, and it printed that out for me, and it printed out the hour. So that's just an example of how functions are stored within modules and how you can call them. So here's another example of the sys module, and we're using the stdin.readLine function within that module. And what that does is it just reads whatever text you type in and it outputs a string. So I typed hello, and it printed out hello back for me. So another example of how I use this is a function. So this is a new tab, or a new shell that I should say. So I went to File, New File, and I typed all of this code out before saving it. What you need to do is, if you're going to be importing a module that you want to use inside of a function, you need to put that into the new shell. You can't just type out import sys into the Python shell, open a new window, try to use the module, save that, and then run it. That won't cross over. If you want to use the sys module or any module, you need to call that import that inside the function before you save it. Go back to the Python shell, run it, and that's where the output will come out. So in this new window, I imported the sys module, and then I'm making a function. It's called silly age joke, and it's empty parentheses because technically we don't have any parameter. We don't have any parameters really. We have values, or variables, I should say, that are storing values later on in the function code. but we're not having any variables that we're using as parameters like right off the bat, if that makes sense. So we're telling the function, or we're telling Python to import the sys module. We define the function as silly age joke. So the person will see this printed out. How old are you? And then the age is equal to the int of this module with this function. So before, when we typed out hello, the read line reads it and outputs a string. And like I said before, if we're converting from strings to numbers, we need to use the int function, which is kind of like it's short for integer, I think, and it just turns the string into an integer. So the person will type in this example, I ran it after I saved it, asked me how old I was, I typed in 19. The int will cut off the quotation marks, so it's just age is equal to 19, just the number. If age is greater than or equal to 10 and age is less than or equal to 13, print what is 13 plus 49 plus 84 plus 155 plus 97, a headache. Also, some of these jokes are not my own. They're from this book that I have been using to teach myself how to code Python. But so that is the joke. It'll print out if the if statement is true. Else it will print, So my age was 19. So age was greater than or equal to 10, but age was not less than or equal to 13. So the else statement ran and it printed, So that is an example of how we can import modules and also how to incorporate them into functions themselves. And now I will just quickly touch on built-in functions in Python. So the abs function just returns the absolute value, pretty self-explanatory. It's just ABS with parentheses. So if I did ABS parenthesis of -3 close parenthesis, it would tell me 3. The bool function. The name bool is short for Boolean, and that's the word programmers use to describe a type of data that can have one or two possible values, usually either true or false. The bool function takes a single parameter and returns either true or false based on its value. When using bool for numbers, 0 returns false while any other number returns true. When you use bool for other values like strings, tuples, lists, or maps that are empty, it returns false. Otherwise, it will turn true. So basically, if you're using something, or if something is empty or it's equal to 0, bool will be equal to false, and if it's not, it'll be equal to true. So in this example, I say print the bool of 0. That's false. Print the bool of 1. That is true. Print the bool of none. None is basically empty. It's the same thing. And that's false. And print bool of the string hi. That's true. So this could be helpful, like if you're asking for an input or something, and the person like accidentally clicks enter, but they didn't like type anything in, then you can do an if statement that says like if the bool of their input was equal to false, tell the person that they didn't input something, that they need to input a value. So an example of that was in this code. I say year equals input year of birth. So this is what it looks like when it runs. So the person will be asked, what is your year of birth? And then in this if statement, if not statements are also a thing. So what this is saying is if not bool, what this is basically saying is if the bool is false. So bool of year dot r strip, if that was true, but it's a not statement, if not. So it needs to be false. And you need to enter a value for your year of birth. So I tested it out. I ran it and it asked me my year of birth and I just clicked enter. I didn't type anything in. So it's empty. So bool is something that's empty is false. So the bool wasn't true. If not bool, that was a true statement because the bool was false. And so it printed out you need to enter a value for your year of birth. So this can be kind of helpful for just like interacting with the person that is inputting stuff into the code. Next up, we have the eval function, and this takes a string as a parameter and runs it as if it were a Python expression. So your calculation is equal to input, enter calculation. So I entered 12 times 10. I said evaluate that variable, your calculation, and it just calculates it for me. The float function converts a string or a number into a number with a decimal place. So if I say float of 12, it tacks on the decimal with the 0. So it gives me back 12.0. We have the int function, which I have mentioned many, many times already. This is very, very handy with input. It converts a string or a number into a whole number. It's short for integer, basically. So essentially everything after the decimal point is dropped, or if you have a string, it will basically chop off the quotation marks and it will just give you back the number. Let's see. But if you try to convert a string with a floating number, you will get an error. And that's because it's kind of confused what to do. It's chopping off the quotation marks, and then it also sees that it needs to chop off the decimal, and it doesn't like doing both things. So in this example, we take int of 123.456. It chops up everything after the decimal and gives you back 123. Int of the string 123, it chops off the quotation marks and gives you back 123. And then this is an example of trying to convert a string with a floating number or that has decimal and everything into an integer, and you will get an error for that. The len function. The len function returns the length of an object, the number of characters in a string, it counts spaces, and the number of items in a list, tuple, or map. So for example, the len function of the string, hey, you rock, is 13. We have the HEY space, YOU space, ROCK exclamation. So we have 13 in that. Animal list, we have bear, giraffe, lion, and penguin. We can ask the length of an animal list matrix, or the list, I should say, sorry. And it has 4 entries. Same with the map, it will give you the amount of keys that you have. So when I showed you the map, it had the keys and then the values. For each key, there was a value. So it also tells you the amount of values. So in the enemies map, we have Batman, Joker, Superman, Lex Luthor, and Spider-Man, Green Goblin. We ask for the length and it gives us back 3. Our values are Batman, Superman, and Spider-Man. Keys, did I say that? Sorry. Keys are Batman, Superman, Spider-Man, and our values are Joker, Lex Luthor, and Green Goblin. The max and min functions will return either the smallest or the largest item in a list, tuple, or string. In this example, in this list, we have 5, 4, 10, 30, and 22. We ask for the maximum value in that list, and it tells us 30. In case of strings, letters are ranked alphabetically and lowercase letters come after uppercase letters. In the example above, little t is after big T. And the way that it does that is it just assigns the letter to the number that it is in the alphabet. So like letter A is just 1 because it's the first letter in the alphabet. B is 2, C is 3, D is 4, and so on. So T is the furthest along in the alphabet. So when we ask for max, it will give us the T in comparison to everything else, it's max. And since it's lowercase and that comes after uppercase letters, it returns us the little t instead of the big T. You can also just enter the numbers into parentheses as parameters of the function, and it will give you back the maximum straight off the bat. So you don't have to make like another list or something. So let's do that here. Max of 123, 34, 56, and 7, and it gives me back the maximum, which is 123. The minimum does the opposite, but all the same rules apply. You can just enter in the parameters right here, and it just returns the smallest item in the list, tuple, or string. The range function, I also touched on this, but just to recap, the range function is mainly used in for loops to loop through a section of code a specific number of times. And this includes the lower number, and it goes until the number before the upper number. It is not inclusive of the upper number. So for example, range of 1 to 6 would be 1, 2, 3, 4, 5. We stop before we get to 6. And then I wanted to print it off, and that's what we see right here. We can also add a third parameter called the step. So if no step is included, Python will count by 1 by default. In this example, however, I'm counting by 2s. So I have the range from 0 to 12, so we would go from 0 to 11. And then this third number is counting by steps, so we're counting by 2s. So it would go 0, 2, 4. Oh, alarm. It goes 0, 2, 4, 6, 8, 10. It would add 2 to 10 and see that it gets to 12, and it would say, no, you can't. It's not inclusive of the top number, so we'll stop at 10 instead of stopping at 11. You can also count down by 2s. So if we're going from 12 to 0, the step just needs to be negative because we're going down. We're going to go from 12. We would want to go to 1, but again, we're counting by 2s, so we need to see if that's not going to happen. We're not actually going to go down to 1. We'll go to 12, 10, 8, 6, 4, and then 2. It will try to subtract negative, or it will try to subtract 2 from 2 to get to 0, and it won't let you do that because it's not inclusive of the second number in the range, as I said before. The sum function adds the items in a list and returns the total. So in this my list of numbers that I made a list with the range from 0 to 500 by 50. So, and then it prints it out. So great, it should look like this. It goes all the way up until 450. It sums it, and it gets me 2,250. All right, I think that is everything for what I have so far. If anyone has any questions on anything, you're always welcome to email me. My email is donah198@umn.edu. But other than that, thank you so much for coming to the second workshop, and I look forward to seeing you all in the next Python workshop. Bye.